AWS Lambda. What is AWS Lambda? 1. Serverless compute service. AWS Lambda allows you to run code without provisioning or managing servers, offering a serverless architecture that simplifies deployment and management. 2. Event-driven execution. It executes code in response to events from over 200 AWS services and SaaS applications, making it highly responsive and efficient for real-time data processing. 3. Auto-scaling capability. Lambda automatically scales your application by running code in response to each trigger, handling the scaling from a few requests per day to thousands per second. 4. Pay-per-use pricing model. With Lambda, you pay only for the compute time you consume, with no charge when your code is not running, making it cost-effective for varied workloads. 5. Integrated security model. Utilizes AWS IAM, Identity and Access Management, to manage access to your Lambda functions securely, ensuring that only authorized entities can execute or invoke your functions. 6. Zero administration. AWS handles all the administration of the compute resources, including server and operating system maintenance, capacity provisioning, automatic scaling, and monitoring. 7. Support for multiple languages. Lambda supports multiple programming languages, including Node.js, Python, Java, Go, PowerShell, and C#, providing flexibility in how you build your applications. When to use AWS Lambda. 1. File processing. Use AWS Lambda in conjunction with Amazon S3 for real-time data processing post-upload, automating tasks like image resizing or data transformation without server setup. 2. Stream processing. Leverage Lambda with Amazon Kinesis for handling real-time streaming data. It's suitable for a wide range of applications such as transaction order processing, data cleansing, and social media analysis. 3. Web applications. Create scalable web applications by combining Lambda with other AWS services. This setup ensures your applications can handle varying loads efficiently and remain highly available across data centers. 4. IoT backends. Develop serverless backends to manage requests from web, mobile, and IoT devices. AWS Lambda can serve as a flexible backend solution, responding to events without the need for continuous server management. 5. Mobile backends. Utilize Lambda alongside Amazon API Gateway for authenticating and processing API requests for mobile applications. Integrate seamlessly with iOS, Android, web, and React Native frontends using AWS Amplify. File processing example. 1. Photograph is taken. This is the initial action where a user or an automated system captures a photo. 2. Amazon S3. Once the photograph is taken, it is uploaded to Amazon Simple Storage Service, Amazon S3. 3. Lambda is triggered. After the photo is uploaded to S3, it automatically triggers an AWS Lambda function. 4. AWS Lambda, image resizing code. The triggered Lambda function contains code that performs image resizing. This means that Lambda will take the uploaded image and resize it into different versions suitable for various devices such as web browsers, mobile phones, and tablets. 5. Photo is resized. The result of this Lambda function is a set of resized images that are optimized for different screen sizes. This is particularly useful for websites and applications that need to display images correctly across a range of devices. Streaming example. 1. Amazon Kinesis captures real-time social media data streams. 2. Lambda triggered. The data stream triggers an AWS Lambda function. 3. AWS Lambda processes the data to extract hashtag trends. 4. Amazon DynamoDB stores the trending data. 5. Data querying. The processed data is immediately available for querying by business users, likely for analytics or reporting purposes. The image describes a serverless architecture for a weather application using AWS services. 1. Amazon S3 hosts the front-end code for the weather application. 2. User interaction. A user requests local weather data by clicking a link in the app. 3. Amazon API Gateway. The app calls an API endpoint through API Gateway to fetch weather data. 4. AWS Lambda. The API Gateway triggers a Lambda function. 5. AWS Lambda. This function retrieves weather data from DynamoDB. 6. Amazon DynamoDB stores the weather data, which Lambda retrieves and sends back to the user. The image depicts a serverless IoT backend process. 1. Tractor sensors. They send data to Amazon Kinesis. 2. Amazon Kinesis, it captures and streams sensor data. 3. AWS Lambda, triggered by Kinesis, runs code to analyze the sensor data. 4. AWS Lambda, it detects data trends, identifies anomalies, and arranges orders for replacement parts if needed. 5. Output, an order for parts is automatically generated. The image depicts a process where 1. A user posts a status update. 2. The post triggers an API gateway. 3. The API gateway invokes an AWS Lambda function. 4. Lambda checks the user's friend list and sends out notifications. 5. Amazon SNS delivers the status update notifications to the user's friends. Key features of AWS Lambda. 1. Configurable function options. Customize your Lambda functions using the AWS Management Console or the AWS CLI to meet specific application requirements. 2. Environment variables. Utilize environment variables to dynamically adjust your function's behavior without needing to update the code, enhancing flexibility. 3. Versions and beta testing. Manage your function's deployment with versions, allowing for seamless beta testing and user segmentation without disrupting the production environment. 4. Container images. Create Lambda functions with container images, using AWS provided base images or your own, to leverage existing container tooling or deploy large dependencies. 5. Layers for dependencies. Package libraries and other dependencies into layers to minimize deployment package size, speeding up the deployment process. 6. Lambda extensions. Integrate additional monitoring, observability, security, and governance tools directly into your Lambda functions. 7. Function URLs. Assign dedicated HTTPs endpoints to your Lambda functions, simplifying direct access via web browsers or HTTP clients. 8. Response streaming. Improve your function's response times by streaming payloads back to clients, particularly beneficial for Node.js functions. 9. Concurrency and scaling controls. Apply detailed controls over your function's scaling and responsiveness, ensuring your applications can handle varying loads efficiently. 10. Code signing. Ensure that your Lambda functions run only unaltered code published by approved developers, enhancing security. Key features of AWS Lambda. 2. 11. Private networking. Establish private networks for your Lambda functions to securely access databases, cache instances, or internal services. 12. File system access. Enable your Lambda functions to access and interact with files stored on Amazon Elastic File System, Amazon EFS, facilitating shared resource manipulation. 13. Lambda Snap Start for Java. Drastically improve startup times for Java-based Lambda functions with Lambda Snap Start, often requiring no changes to your existing code. AWS Lambda language support. AWS Lambda natively supports Java, Go, PowerShell, Node.js, C#, Python, and Ruby code, and provides a runtime API which allows you to use any additional programming languages to author your functions. In this example, the Lambda function takes a JSON object containing two integer values labeled length and width. The function multiplies these values to calculate an area and returns this as a JSON string. Lambda function also prints the calculated area, along with the name of its CloudWatch log group. Lambda function contains a Python function named lambda_handler. A Lambda function in Python can contain more than one Python function, but the handler function is always the entry point to your code. When the function is invoked, Lambda runs this method. The function lambda_handler takes two arguments, event and context. An event in Lambda is a JSON formatted document that contains data for your function to process. The second argument the function takes is context. Lambda passes the context object to the function automatically. The context object contains information about the function invocation and execution environment. You can use the context object to output information about the function's invocation for monitoring purposes. In this example, the function uses the log_group_name parameter to output the name of its CloudWatch log group. Advanced features in AWS Lambda. 1. Scaling. AWS Lambda automatically scales your application by running code in response to each trigger. The function's execution increases or decreases automatically, ensuring high availability and performance. 2. Concurrency controls. Manage the number of simultaneous executions of your Lambda function to optimize performance and prevent overconsumption of resources. 3. Function URLs. directly invoke your Lambda functions via dedicated HTTP URLs, simplifying the integration with web-based applications. 4. Asynchronous invocation. Execute functions asynchronously to improve throughput and reduce latency. This method queues messages before processing, enhancing reliability. 5. Event source mappings. Connect your Lambda function to external sources like DynamoDB, Kinesis, or SQS, allowing for real-time data processing and interaction. 6. Destinations. Define where to send data after your Lambda function executes, enabling seamless data flow to services like SNS or another Lambda function. 7. Function blueprints. Predefine templates for Lambda functions that help you get started quickly with common use cases, reducing development time. 8. Testing and deployment tools. Utilize integrated tools within AWS for testing your Lambda functions and deploying them efficiently, ensuring reliability and scalability. 9. Application templates. Start your project with application templates that provide a pre-configured set of resources and Lambda functions, accelerating development and deployment. Asynchronous invocation in AWS Lambda. Synchronous versus asynchronous invocation. Understand the difference. Asynchronous invocation waits for a response, while asynchronous does not, allowing for decoupled processing. Queuing and immediate response. With asynchronous invocation, events are queued by Lambda, and an immediate success response is sent back, indicating the event has been accepted for processing. Automatic retries. Lambda automatically retries if the function errors or is throttled. This feature enhances the reliability of the processing without manual intervention. Custom error handling. You can configure error handling settings for your function to manage retries or direct failed invocation records to specific destinations, such as a dead letter queue. Dead letter queues and destinations. For events that fail processing, configure Lambda to send them to a dead letter queue or another destination, ensuring you can handle or analyze these events later. To process items from a stream or queue using AWS Lambda, you can create an event source mapping. This resource allows Lambda to read items from an Amazon SQS queue, an Amazon Kinesis stream, or an Amazon DynamoDB stream and send them to your function in batches. Key features of event source mappings. Batch processing. Event source mappings read items in batches and send them to your Lambda function. Each event processed by your function can contain hundreds or thousands of items. Local queue management. Maintains a local queue of unprocessed items and handles retries if the function returns an error or is throttled. Batching behavior customization. Allows customization of batching behavior and error handling. You can specify a batching window and batch size to optimize the processing. Error handling and destinations. Configurable to send a record of items that fail processing to a specified destination for further analysis or correction. How it works. Lambda polling. For Amazon SQS, Amazon Kinesis, and Amazon DynamoDB streams, Lambda polls the service for items and invokes your function synchronously with a batch of records. Customization options. You can configure the batch size, number of records, and the batching window, time to gather records, to manage the payload size and frequency of invocation. Error handling. Supports configurations for handling errors, including retries and sending failed batches to a designated destination for analysis or reprocessing. This mechanism enables efficient, scalable processing of streaming data or queue messages, offering a powerful tool for building responsive, event-driven applications in the AWS ecosystem. Destinations in AWS Lambda. Asynchronous invocation destinations. Lambda allows the configuration of destinations for asynchronous invocation records, directing them to a queue, topic, function, or event bus for further processing or analysis. Configurable for success and failure. You can set up separate destinations for records of successful invocations and for events that failed, optimizing error handling and success tracking. Invocation record contents. Each record includes detailed information about the event triggered, the response from the function, and the reason why the record was sent to a destination, offering insights for debugging and monitoring. Stream-based event source mappings. For event sources like streams, Lambda can forward records of batches that failed processing to a designated queue or topic, allowing for targeted troubleshooting. Failure record specifics. Failure records contain metadata about the batch and pointers to the specific items in the stream that triggered the error, aiding in precise error identification and resolution. Lambda integrations. 1. Amazon Alexa. 2. Amazon Managed Streaming for Apache Kafka. 3. Self-Managed Apache Kafka. 4. Amazon API Gateway. 5. AWS CloudFormation. 6. Amazon CloudFront, Lambda at Edge. 7. Amazon Event Bridge, CloudWatch Events. 8. Amazon CloudWatch Logs. 9. AWS Code Commit. 10. AWS Code Pipeline. 11. Amazon Cognito. 12. AWS Config. 13. Amazon Connect. 14. Amazon DynamoDB. 15. Amazon Elastic File System. 16. Elastic Load Balancing, Application Load Balancer. 17. AWS IoT. 18. AWS IoT Events. 19. Amazon Kinesis. 20. Amazon Data Firehose. 21. Amazon Lex. 22. Amazon MQ. 23. Amazon Simple Email Service. 24. Amazon Simple Notification Service. 25. Amazon Simple Queue Service. 26. Amazon Simple Storage Service, Amazon S3. 27. Amazon Simple Storage Service Batch. 28. Secrets Manager. 29. Amazon VPC Lattice. 30. AWS X-Ray.